This video will attempt to tackle buffer calculations. Quite often an area that students really dislike and get a bit frightened about, but hopefully we'll show you that there's nothing to be worried about here. Let's have a look at the Ka expression. So we've seen this before, and when we were dealing with a weak acid, one thing we were happy to say, and this made things easier, is that the concentration of hydrogen ions was the same as the concentration of the salt. However, with an acidic buffer, this is not true. The difference here with an acidic buffer is that we now have fairly large quantities of the weak acid and its salt, and they're very large compared to the amount of HA. So what we'll invariably have to do with a buffer calculation is to rearrange the Ka expression to make H plus the subject and allow us to work out the pH of the buffer. So we'll see this a lot. So here it is again in the notes, and as the expression says, the pH of the buffer, and of course the pH of the buffer is going to be dependent on the hydrogen ion concentration, and that depends on two things, one being the Ka value and the other is the ratio of the acid to the salt, and that's that part there. In our first example calculation, we need to work out the pH of a buffer. We're given everything we need, so we have the concentration of ethanoic acid, so that's 0.1. We have the concentration of the sodium ethanoate, which is 0.05, and we've been given the Ka for ethanoic acid, which is that. So we just need to put these numbers into that equation, and if you've done that, hopefully we get 3.52 times 10 to the minus 5. Not quite there. Yeah, that's the hydrogen ion concentration. To get the pH, we just want to do minus log of that, which to 2 decimal places is 4.45. This table illustrates what happens as we change the acid to salt ratio. In the first example, the acid concentration is twice that of the salt, so that's the one that we just did, where the hydrogen ion concentration is going to be twice Ka, and the pH came out to be 4.45. In the second example, the acid and salt concentrations are the same, which means the hydrogen ion concentration will be the same as Ka, which was 1.76 times 10 to the minus 5, and that gave a pH of 4.75. So we can see as the salt increases, the pH also increases, and in the final example where the salt concentration is twice that of the acid, the hydrogen ion concentration comes out to be 8.8 times 10 to the minus 6, giving a pH of 5.06.